Okay, welcome back to lesson 7.3. Again, we're looking at our double angle formulas, and we've got them summarized here in the box. 1 for sine of a double angle, 3 for cos of a double angle, and 1 for tan of a double angle. So what's the point? What can we use these formulas for? We can use them to simplify some expressions. We can determine some exact values. We can prove identities, which I'm not going to do in this lesson. I will take a look at that in another lesson, and then we can solve trig equations, which again I'm going to look at in some later on lessons in chapter 7. So just looking at the first two in today's lesson. So simplifying expressions. So sometimes they're going to give me an expression, it's looking complicated. I'm going to try to make this a little bit simpler. This question is asking me to do two things. The first thing, I need to write it as a single trig ratio, that's step 1, and then I need to evaluate, that's step 2. So I'm going to make sure I do those two things in this question. Now, when I look at this, one of the things I might try to do is identify a special angle, and we have pi by 8 here, not a special angle, so that's not helpful for me. But what I do notice when I look at this is that it looks kind of like our double angle formula. So that double angle formula for cosine that looked like this. So I'm noticing there that kind of looks like my formula. So I've got, this is one of my two theta formulas. But here we've got that theta is pi by 8. So this is all kind of just my thought process. So now I'm going to start the question in green here. So I've got 2 cos squared. And I'm going to rewrite this using cos of 2 theta. But again, I'm not doubling theta, I'm doubling pi by 8. And then I'm just going to simplify what I've got in the bracket there. I've got 2 times pi by 8. I can reduce that. This is like 2 pi by 8s, and 2 over 8. That's the same as 1/4 or 1 over 4. But we've still got that pi on top. So this is just cos of pi by 4. Now I know what cos of pi by 4 is. That's just root 2 over 2. That's one of my special triangles. Or you might have written 1 over root 2 and then rationalize the denominator. So notice the question asked me to do two things. The first thing it asked me to do, I did right here. I wrote it as a single trig ratio. And the second thing it asked me to do was evaluate. I've done that here. All right, the next question, we're going to state the exact value of sine of 2 theta if I know that tan of theta is 8 over 15. Okay, so to get started with this, there's kind of two thought processes that I'm going through. I know that I'm dealing with theta. So instead of dealing with sine of 2 theta, I want to get rid of the double angle. And so I use my double angle formula to write this in terms of just theta. So that tells me that it's double sine theta times cos theta. So I'm going to come back to that. Now, my problem is that I have tan theta and I need sine and cos. So SOHCAHTOA tells me that I need the opposite over the hypotenuse and the adjacent over the hypotenuse, but I have the opposite and the adjacent. So I'm going to draw a picture of this. Now I'm dealing with 0 all the way to 2 pi. So I actually have to think about all the different quadrants. And if I have a positive tan ratio, there are 2 possible quadrants that I'm in. I'm either in the A quadrant or I'm in the T quadrant. And then from both of those terminal arms, I can connect to the x-axis and make a 90-degree angle. And then I know that tan is the opposite over the adjacent. So I know that the opposite side for my angle, and I'm going to just put some betas in here and talk about my related acute angle. My opposite is 8 and my adjacent is 15. Now when I look at this, beta is a decimal, right? Because I don't recognize this 8 over 15. This makes me kind of sad. because I want the exact value here. So I don't want to deal with decimal angles and then get decimal ratios. So what I'm going to do instead is think about the fact that, well, if tan is opposite over adjacent, I can also figure out sine and cosine using opposite, adjacent, and hypotenuse. So I wish I knew the hypotenuse. So I'm going to use SOHCAHTOA, and so therefore I need the hypotenuse. All right, so let's figure out the hypotenuse. So the hypotenuse is going to be c squared equals a squared plus b squared. And it's going to be 8 squared plus 15 squared, which comes out to 289. And so then c is just going to be 17, the square root of 289. Again, I don't need to worry about the positive and the negative square root because I'm talking about a side length of a triangle. So 17 is my hypotenuse. I'm going to come back up and add that to my picture. And now this is going to help me figure out what sine of theta is. Now notice that there's two different thetas. There's sine of theta 1 here. Oh, sorry, a sine and cosine of theta 1. And then there's also a theta 2 over here. So I'm going to split my solution and I'm going to look at both of those separately because they're going to do different things to the sine and to the cosine. So I'm going to go sine of 2 theta 1 is equal to 2 times. Now if I'm looking at theta 1, then I'm looking at the sine being in the A quadrant, so the opposite is 8 and the hypotenuse is 17. And it's positive because I'm in the A quadrant. And then for cosine, I'm looking at the adjacent over the hypotenuse, 15 over 17, and it's also positive because I'm in the A quadrant. But when I look at, I'm going to come back and finish that up in a second. But when I look at sine of theta 2, I have to consider the fact that I'm in the T quadrant. And I do want to see this. So here, for sine of theta 2, I'm going to get that the sine ratio of theta is negative. And it's the same value, it's still 8 over 17, but now it's negative because I'm in the T quadrant. And then for the cosine ratio, again, same value, 15 over 17, but now I'm in the T quadrant, so the cosine is negative. And now I'm going to multiply all the numerators together, so if you want to remember that 2 is the same as 2 over 1. And I'm just multiplying 2 times 8 times 15, and I get 240. And multiplying on the bottom 17 times 17, I get 289. And what you notice over here is you actually end up with the exact same answer because you've got a negative times a negative, which gives you back a positive. But remember, I do want to see both, so I want to know that you thought about the fact that they were both negative or they were both positive. If the question was asking about an angle that ended up in the S quadrant, you would end up with two different answers. You'd end up with one positive and one negative, and I would want to see you think through both of those as well. So here I can say that the final answer is just, sine of 2 theta is equal to 240 over 289. And that's it for this lesson. Enjoy your homework.